This is INTECH's standard wellhead control panel product for a single triple SV. Let's walk up to one of these hydraulic panels to see a demonstration of its functionality. Okay, let me first introduce the items which are on the operator panel. On top right we have the pump header pressure. And then we have the regulator pressure, which is triple SV interface valve inlet. And then we have the triple SV pilot pressure. Below this we have the interface valve manual override knob. We have the high pressure regulator, the ESD emergency shutdown, pull to shutdown button. We have the fusible loop pressure, the pull to charge relay, and low pressure regulator to charge the fusible loop. As you see now that we have a header pressure available which is just over 9,000 psi. We have a regulated pressure of about 7,000 psi at the triple SV inlet, and then we have a header of about 100 psi for the fusible loop. The fusible loop is not charged at the moment. It is completely discharged, and so we see that there is no triple SV pilot pressure available right now. We have this feature with this interface valve that we can have a manual override with this relay, and irrespective of the status of the fusible loop or the ESD, we could basically provide a triple SV pilot pressure. So let me just demonstrate first that. I'm just gonna turn this knob to manual override, and irrespective of the state of the fusible loop, it will generate triple SV pilot pressure. And as you see, as you've just seen now, that we've got 7,000 psi, the regulated pressure at the pilot, the triple SV pilot pressure gauge. So now I'm going to turn this back to pilot operated mode, and you see the pressure falling on the gauge. And now this will be only operated by the fusible loop pressure. So to charge the fusible loop, I'll have to pull this fusible loop relay for a few seconds, and as soon as the pressure is developed over here on this gauge, which represents the fusible loop pressure, or triple SV pilot pressure will be generated. The triple SV relay, interface relay, will be open, and the pressure will be seen on this gauge right over here on the top left corner of our panel. So I'll just go ahead and pull this relay, and we see the pressure building. As soon as there is enough pressure, we can see that this triple SV pilot pressure has been generated. So this is a summary of the operations that would be conducted on the operator panel side of this single triple SV wellhead control panel. Now I'll just take you to the maintenance side of this panel. This is the maintenance access door, where you can see that we have a pulsation damper, which is also acting like as an accumulator in this case. We have a manual pump right here. Behind that we have an electric pump motor package. Then we have the batteries, and all the interior components or the interior walls of this panel are well insulated with heat and fire resistant and moisture resistant insulation material. In this junction box we have the control circuitry to automatically turn the motor on and off and control the operation of the motor and the heaters inside this panel. In the current demonstration, the pump, we've already charged the accumulator, and there's enough volume in the accumulator to run several cycles of demonstration. Up here we have temporarily placed the field transmitter to get the feedback from the field. and to make sure that uh, all the cause and effects are incorporated before we turn on the solenoid. Up here we have, let me just quickly introduce the components. Apart from the components which are visible on the front panel, we have the accumulator bottle over here. We have a filter module right behind it, and then we have the panel heater, the reservoir door, the reservoir itself, and we have another 400 watt heater over here, and we have a level switch which is connected from over here, and up here we have a solenoid which is again connected to the junction box. So this is all about this hydraulic panel, and